the ellipses, and then it's just kind of practicing some of those problems before we start the hyperbola, the last function, or the last conic, not function, conic tomorrow. So used to doing functions. So we'll look at that tomorrow. So remember, a little warning in advance. Tomorrow is going to be a little heavy on the material, the concepts that we're going over, because it's introducing that hyperbola. Luckily, it has a lot of common parts of the ellipse, so you'll see that there are a lot of similarities between the two, but it'll be a little intense tomorrow. So if you want to look at your homework, just taking a peek at number 25. Number 25 was a problem that it gave you the vertices, and those vertices were at 0 and positive or negative 5. And then it also gave you a point that it passed through, and that point was at 4, 2. And it said, find the standard form of the equation. So how do we know if this graph is vertical or horizontal? Without really doing anything at all, how do we know if it's vertical or horizontal? Peter?
Since the y changes and the vertices, it's going to be vertical.
Yeah, so whatever variable is changing in the vertices or in the foci, that tells you the direction that it's going. So this graph is a vertical graph. That means that the A value has to be underneath the Y. I'm sorry, that's kind of sloppy looking there. So if the vertices are at 0 and positive or negative 5, Jenny, what's the center of this graph?
It would be at 0, 0.
Yeah, the center is at 0, 0. So technically x minus 0, y minus 0. And then Jenny, if the center is at 0, 0, and the vertices are up at 5 or down at 5, the A value would be?
5.
Yeah, the A value is 5. So I can take this out and change it to 25. Square it when you're placing it underneath there. So vertical means the bigger number is with the Y, and the bigger value is A. So that's going underneath the Y. The center is at 0, 0 because the vertices are on the Y axis, up at 5 or down at 5, the same distance from 0. So after you have that information figured out, the other piece that they give us is that ordered pair. So if you're given an ordered pair, Darby, what do you do with the ordered pair, the point that the graph passes through?
You would plug it in for x and y.
So plug it in for x and y. And then what happens, Darby?
So then obviously anything subtracted from 0 is the same number. So it would just be 4 squared and 2 squared, which is 16 and 4.
Yeah.
And then after that, you would subtract the 4/25ths to the other side. So you could cross multiply to find b squared.
Nice, good. So subtract 4/25. This is 25/25. So we have 16 over b squared. And then that gives us 21 over 25. So you do want to square the number on the top. Don't just leave it as 4 squared or 2 squared. Actually square that number because your goal is to solve for b squared. And Darby said you do need to cross multiply. So we would have 21b squared. And 16 times 25 is 400. You're solving for b squared. You don't need to take the square root of it because the equation, the standard form, has b squared in it. So when you divide by 21, you're going to leave it as 421st. And then that's your b squared value. So I can take out my b squared and I can replace that with 421st. So the standard form of the equation, the center was 0. So it's just x squared over that b squared value, 421st. It's just y squared. That number is over the a value, which we found from knowing the vertices, so that's 25. And then it's equal to 1. So find the center. If you're given the vertices, you have to recognize that that distance from the center to one vertex is a, and then use the ordered pair for x and y. Any questions on 25?
So can you just leave the fraction in the denominator?
Yes, you know what? That's the way the book has it. And I would probably argue that no, it shouldn't be left like that. If you were graphing it, you want the fraction in the denominator as the 421st because you need to know the b value. But any other time you're writing an equation, we never leave a fraction in the denominator because it's considered an unsimplified equation. So the book and I would have to argue a little bit, and I bet any other math teacher in our department would say the same thing. The 21 in the denominator would move back to the numerator. And you would see it written as 21x squared over 400 minus y squared over 25 equals 1. So the book and I would have to argue, but I didn't write the answer key in the book. But I mean, 99% of the time, you don't leave a fraction in the denominator if you're writing an equation. You don't keep a fraction within a fraction. It's considered unsimplified. The reason we keep a fraction or we have that fraction in the denominator would be so that we could know the entire b squared term if we were graphing it. But really a standard equation, you should have that fraction out of complex form. Good question, Hannah. Any other questions? So that 21, the 421st, that 21 that you're dividing by just bumps back into the numerator. 21x squared over 400. All right. So as I said, we're going to do a really quick summary. And I think your assignment posted, it was supposed to post at 9. But I know from last week that Google Classroom is sometimes slow. Yeah, I think it's posting right now because it won't let me take off. Yeah, so it should be there. It looks like it literally just posted. So if you want to go to Google Classroom and pull up the 9192 review worksheet. Joe, do you have a puppy? Or is your icon just a cute little puppy that you thought was cute? Or is that your dog, Joe?
No, it's not mine. But
Oh,
my sister does have one that looks kind of like
like
that.
that. Oh, it's so cute. Addie would love a puppy, but we have a zoo already. We have a bunny and a cat and a gecko and fish. Who needs a puppy? And they're a lot of work. All right, so looking at the standard form of a parabola. So this is just a summary sheet to help you kind of pull things together. We know the parabola has one vertex, and that vertex is at H and K. When the parabola is a vertical parabola, does anybody remember the standard form of the equation for a vertical parabola? Peter, what do you think?
Is it y is equal to x squared?
So generally it would be y equals x squared, yes. That would be the algebraic function that we worked with. So the x has to be squared, and that's the
Would it be
key thing. So what does it look like for a conic?
would it have to be a times x minus h squared plus k?
You're close. You're on the right track. You're giving me the algebraic one again. Jenny, do you want to help him out? Do you remember? I tried to fill in a shell here.
Is it y minus k squared equals 4p times x minus h?
And you're close as well. How about
Is
x
it
minus
the
h
x minus
squared?
h squared?
Yeah. And then y minus k with that 4p in front. So Peter, you were giving me the correct algebraic form with that x being squared, that x minus h squared. But in the elliptical, or not the elliptical, the conical definition of a standard form of a parabola, x minus h squared on the left, on the right is 4p, and that p is the distance from the focus to the vertex or the directrix to the vertex, and then y minus k. So the focus, if this is a vertical graph, you're adding p to the y value of the vertex. And then the directrix, you're subtracting p. So the focus is the same distance as the directrix is to the vertex. So you add or subtract p. And again, it's the y value since it's vertical. So this is the one that x is squared, making a vertical parabola. And that is our traditional graph. So Jenny, you gave me the horizontal equation originally, y minus k squared, 4p x minus h. And that makes a horizontal graph because when you plug in a number for x, you get a value above and below that for y. So you have the graph then moving horizontally left or right, and it's not a function because you have one x and two y values, but it goes horizontally. Since it's a horizontal graph, when you look at your focus, the x value is the one that's changing. And again, p is the distance from the vertex to the focus or the directrix. So that standard form, vertical, the x is squared. Horizontal, the y is squared. And that's different from the others. One squared term as well. So when you're thinking about, is it a parabola, your parabola has one squared term. All right, so the next one here is what we just worked on, the standard form for an ellipse. Again, we have vertical versus horizontal. I tried to keep vertical on the left, horizontal on the right. So when it's a vertical ellipse, you have an x minus h squared. You have the y minus k squared. It's supposed to be equal to 1. What makes the standard form of an ellipse be a vertical ellipse? Peter?
Would it be when the a value is under the y?
Exactly. So it's the location of that a value. And a is the bigger number. So the bigger number being with y makes it vertical. The graph is stretching further up and down compared to left and right. So when you go to write the horizontal standard form, it's still x minus h squared, y minus k squared equals 1. The difference is the location of the bigger number. So if the bigger number is with x, then it's horizontal. So with an ellipse, you're focusing on the denominator, which one's bigger, and then which variable is it paired with. The center is h and k. So the parabola, vertex h and k, but an ellipse, the center is h and k. So to find the vertices, vertical means the y value is going up or down. Vertices use the value of a. The foci, remember there's a c in foci, that uses the value for c. And again, you can see the y value is changing because it's vertical. And then our horizontal graph, the x value should change. So if it's moving left or right, x moves left or right. That should be the part that's changing when you're finding your vertices. The vertices should be left and right. The foci should be left and right. So you should always have 5 points lining in the same line. If it's horizontal, 5 points on the same horizontal line. That's called the major axis. If it's vertical, then you should have those 5 points lining up vertically on that same major axis. And then the last thing that maybe you want to remind yourself, c squared is a squared minus b squared. So the other equation that we worked on, which I omitted from this, would be our circle equation. So I'll just place this down here as a little reminder. This circle still has an x minus h squared, a y minus k squared. But a circle is just equal to r squared. A circle doesn't have any fractions underneath it, any values to make it a fraction, I should say. So the number is not going to be 1 on the right. That number is going to be something else to represent the radius. And then the center is still h and k. In my opinion, the circle is the easiest one to graph. It's the easiest one to find. It just has a center and a radius. Are there questions? So this is a great summary sheet for you to use as a nice study aid to kind of think about the 3 conics that we've looked at. Tomorrow we'll do that one final conic called a hyperbola, and it'll be similar to the ellipse. So the vertices are going to be the same, the foci are going to be the same, but there's going to be a little switch in the equation to make it a hyperbola instead of an ellipse. And of course, the definition will have just a slight difference as well. So there are 9 problems underneath. And the first group of problems are dealing with the ellipse. So find the standard form, find the center, the foci, the vertices, make a sketch of the graph. Number 2, find the standard form, but you're given vertices and foci. And again, it does say make a little sketch of the graph. And it kind of bounces back and forth between what you're asked to do. But the first group of problems deal with the ellipse, and then it'll move to the parabola. There is an answer key attached, so you can check your answers. You do not have to remain on. So today is a wonderful Wednesday, where it would have been a practice day if we were in class and you're at home and it happens to fall on a Wednesday. So it is a practice day. You just get to practice from the comfort of your own home. But please know I will still be here, so that if you run into a problem, feel free to join Zoom and I can answer any questions that you have. Does anybody have questions right now to ask? Any clarification?